See, if I'm taking some nucleus beta, like say for example C, isn't it? And we are reacting it with some attacking particle, like say for example small c. C is what from your initial nuclei. C is what from your initial nuclei. And this small c is your some attacking particle. Okay. So when these two reacts, we get a end product that is nothing as D. D is nothing but of your end product. D is your end product followed by some emitting particle. Followed by your some emitting particle, which is in the form of what? Some radiations.
Yes, sir.
Isn't it? And take capital C is your initial nuclei, and small c and d are attacking particle and the radiations. And finally, we are getting a product that is nothing but of your D. Nuclear reaction is a phenomenon basically.
Yes, sir.
Chemistry కూడా ఎట్లా రాస్తాం కదా?
అవును.
ఏమైనా రాస్తామా?
ఇట్లానే రాస్తాం సార్.
బేసిక్ రియాక్షన్ బేట ఎక్కడైనా కూడా ఇదే విధంగా రాస్తాం మనం, అవునా కదా?
Yes, sir.
Tell me, if this is your atom, you know that at center we are having a nucleus, that is Z into E, which are having protons and neutrons, isn't it? Let's say for example, in this one, there are the protons and as well as of your electrons. So because of the protons and electrons, the forces acting on this one is, this is your proton. On the proton, there will be the force, nuclear force inside, and there will be your electrostatic force in the outward direction. The proton wala, there inside there will be a nuclear force, and outside because of the electrons, there will be an outward force. So one is electrostatic force acting in the outward direction, and another is neutral particles. That means nucleus is exerting the force on this particle.
Yes, sir.
So F is your repulsive electrostatic force. This Fn is your net attractive nuclear force. But రెండిట్లా ఒకవేళ రెండు ఈక్వల్ అయితేనే this atom will be stable, or the nucleus will be the stable. అంతే కదా?
Yes, sir.
If Fe is equals to your Fn, then only we can say that nucleus is stable. Nucleus is stable. Fe అంటే ఏంటన్నా? Repulsive force, electrostatic repulsive force, and Fn is nothing but of your nuclear force.
Yes, sir.
I hope you know that nuclear force are the strongest force, and they are short range in the relation. Gurtunda?
Sir.
Nuclear force is strong attractive force of all them. Strong attractive and short range force. Short range force. Which is the longest range force, beta? Gravitation.
Yes,
gravitation
sir.
can exist from the surface of the earth to the moon and as well as sun, whereas nuclear force may exist only up to some kilometers, maybe 10 kilometers, 20 kilometers, 15 kilometers. So nuclear force is no doubt the strongest of all the forces, but they are very short in the range. Okay na?
Yes, sir.
And weakest of all the forces is gravitation, but longest of all the forces is the gravitation.
Yes, sir.
Okay?
Yes, sir.
So I can say here right now, force between neutron must be equal to force between a neutron proton, and that will be equal to force between proton and proton in nuclear force. Okay.
Yes, sir.
What is this one, beta? Element representation. A represents me what, beta, here?
Sorry, sir.
What does A represents? Mass number.
Mass number. Z
Z represents me for me atomic.
atomic number.
This is your atomic number. Okay. Sure. Next one is nuclear size. Nucleus size. The size of any nucleus is directly proportional to what? Atomic mass,
Yes, sir.
isn't it? So I can size means volume.
Yes, sir.
So I can say here size of nucleus is directly proportional to your atomic mass. Nucleus is spherical, so it will be volume 4 by 3 pi into your r cube is directly proportional to your mass number. Okay, simplifying this one, we'll be getting the relation r is equals to your r naught a to the power of 1 by 3. This is the standard formula you need to remember to find the radius of your nucleus. R naught is a constant beta. Value of this R naught is given in Fermi. That is R naught is equals to 10 to the power of minus 15 meters. Okay.
Yes, sir.
Very important relation beta. R naught is known as what beta? Some Fermi constant. This one is known as a fever Fermi constant. Scientist Fermi has told you about this relation. That is the reason we are calling that constant as of your Fermi constant. Now tell me, if the radius of the nucleus is been increasing, what happened to the nuclear force?
Decreases.
What happens? If radius is
Decreases.
increasing, yeah, because as the size increases, nuclear force will be decreasing. So if the radius is been increasing, nuclear force will be your decreasing. So nucleus will become stable or unstable?
Unstable.
Yeah, so nucleus gets unstable. That means decay starts. Isn't it? I'll say some element X is there. It will give you some product Y plus along with that one some radiation. Isn't it?
Yes, sir.
Very important relation. R is equals to your R naught a to the power of your 1 by 3. Clear, beta?
Yes, sir.
R naught value మనం exact గా నాకు రాసుకుంటానన్నా. This value is R naught is equals to your 1.2 Fermi. Isn't it? That is equals to your 1.2 into 10 to the power of minus 5 meters. Sorry, 10 to the power of minus 15 meters. అంతే కదా? Because 1
Yes,
Fermi
sir.
is equals to how much? 10 to the power of minus 15 meters. R naught value is 1.2 Fermi, or it is 1.2 into 10 to the power of minus 15. So radius and mass numbers are directly proportional to each other, beta. So I can write here one point for this one. R1 divided by your R2 is equals to your A1 divided by your A2 to the power of 1 by 3.
Yes, sir.
Isn't it? That means mass numbers are directly proportional to what, beta? Ratio of their masses?
Yes, sir.
isn't it? A is your atomic mass. So I can say that A1 divided by your A2 will be equal to your M1 divided by your M2. Got it?
Yes, sir.
One more thing you need to remember is, as it is an internal forces beta, momentum is conserved. So initial momentum will be equal to your final momentum. M1 V1 will be equal to your M2 into your V2. That means I can write from this one, M1 divided by your M2 will be equal to your V2 divided by your V1. Okay.
Yes, sir.
So I can write radius R1 divided by R2 is equals to your. I can write the mass in the place of your M1 A1 by M2. I can write M1 by M2 to the power of your 1 by 3. Or else I can write here R1 by your R2 is also equal to M1 by M2 is directly proportional to velocity. So it is V2 by V1 to the power of your 1 by 3.
Yes, sir.
So therefore ultimately I can write here R1 by your R2 is equals to your A1 by your A2 to the power of 1 by 3 and రాసుకోవచ్చా? లేకపోతే I can even write this one as of your M1 by your AM2 to the power of 1 by 3 and కూడా రాసుకోవచ్చా? Or else I can even write this one as of your V2 divided by V1 to the power of 1 by 3 and కూడా రాసుకోవచ్చు. అవునా కదా?
Yes, sir.
This is the standard formula you need to remember. Done?
Yes, sir.
To the question you answered. Next, say for example, a nucleus disintegrate into two nuclear parts. Into two nuclear parts which have their velocities in ratio 2:1. Okay.
Yes, sir.
Find the ratio of nuclear size. Tell me, what will be the answer? Nucleus is being disintegrating into two parts. Like say this is a nucleus, this is disintegrating into two parts like this, which are having their velocity. This is having 2 and this is having 1. So this is your V1 and this is your V2. He's asking the ratio of their nuclear sizes. That means then radius R1 and then radius R2. So R1 by R2 is how much? R1 by R2 is equals to V2 by V1 to the power of 1 by 3. Isn't it? So it will be 1 by 2 to the power of 1 by 3. Antena?
Yes, sir.
What an idea?
Yes, sir.
Sure. Next one is, in this one very important point which you need to remember. What do you mean by your nuclear binding energy? Nuclear binding energy. Nuclear binding energy. What's in that? So what do you mean by nuclear binding energy, beta? The energy which is required to separate an atomic nucleus completely into its constituents. What are the constituents like proton and neutrons? Are equivalently, that energy would be liberated by combining the individual protons and neutrons into a single nucleus is called as of your binding energy.
Yes,
Okay.
sir.
So what exactly is the binding energy? The energy required to separate the atomic nucleus. Atoms lo emuntayi manaku nucleus. A nucleus lo emuntayi manaku protons and as well as of your neutrons. దాన్ని సెపరేట్ చేయడానికి అయితే మనకి ఎనర్జీ అవసరం అవుతుందో ఆ ఎనర్జీని మనం ఏమంటున్నాము న్యూక్లియర్ బైండింగ్ ఎనర్జీ ఆర్ ఈక్వివలెంట్ వాట్ ఐ కెన్ సే ద ఎనర్జీ దట్ వుడ్ బి లిబరేటెడ్ బై కంబైనింగ్ ది ఇండివిజువల్ ఒక ప్రోటాన్ ఒక న్యూట్రాన్ ని కంబైన్ చేసినప్పుడు ఏదైతే సింగిల్ న్యూక్లియస్ ఫామ్ అవుతుందో అప్పుడు ఫామ్ అయ్యే ఎనర్జీ ఆ లిబరేట్ అయ్యే ఎనర్జీని కూడా మనం ఏమంటున్నాము న్యూక్లియర్ బైండింగ్ ఎనర్జీ అంటున్నాం. ఇస్ దట్ క్లియర్? సో కెన్ ఐ సే దట్ ద ఎనర్జీ రిక్వైర్డ్ to separate an atomic nucleus. An atomic nucleus completely into its constituent protons and neutrons.
Yes, sir.
Or I can even say that it is your equivalently the energy that would be liberated by combining individual protons and neutrons. అంతే కదా, individual protons and neutrons into a single nucleus.
Yes, sir.
Into a single nucleus is called nuclear binding energy. Once again, energy required to, it is your what? Energy required to separate an atomic nucleus. Atomic nucleus name of protons and neutrons. So completely into its what beta? Into its protons and neutrons is called as binding energy. Or equivalently the energy that would be liberated by combining. అంటే ఒకసారి బ్రేక్ చేసిన తర్వాత అగైన్ మనం కంబైన్ చేయాలనుకుంటున్నాం proton and neutron. So equivalently the energy that would be liberated by combining the individual proton and neutron in a single nucleus is also called as of what? Binding energy. Is that clear?
Yes, sir.
చూడు ఇప్పుడు బైండింగ్ చేసేటప్పుడు ఏమైపోతుంది? Z into your proton plus number of neutrons and A minus Z into your neutrons must be giving you the formation of your some nucleus Z into your A plus certain energy with that one. That energy is known as what? Binding energy. This one is known as of your binding energy. అర్థమైందా? ఒక ప్రోటాన్ అండ్ ఒక న్యూట్రాన్ రెండు కంబైన్ అయినాయి మనకి ఏదైతే ఎలిమెంట్ ఇస్తుందో ఆ ఎలిమెంట్ వచ్చే ఫార్మేషన్ లో ఏదైతే ఎనర్జీ లిబరేట్ అవుతుందో ఆ ఎనర్జీని మనం బైండింగ్ ఎనర్జీ అంటాం.
Yes, sir.
క్లియరా?
Yes, sir.
So I can keep one small note here right now. When reactants combine to form stable products, there is mass loss. When reactants combine to form a stable product, there is a mass loss. That mass loss is called as what beta? Mass defect. Is called as what? Mass defect. So when reactants are combining to form the stable product, there is certain loss of the mass. That loss in the mass is only called as of your mass defect, represented by letter delta M. So I can write here mass defect will be equal to your, this will be equal to your mass of your protons plus of your number of your neutrons A minus Z into mass of neutrons minus this is the mass of the element whichever it is been formed. Okay, na?
Yes, sir.
So what is the mass defect right now? So mass defect is nothing but whenever the reactants are being combining to form a stable product. This is a stable product, whatever it has been forming. There is a mass loss. That mass loss is only called as mass defect. So what is the formula I can write for the mass defect beta? Delta M is equals to when proton and neutrons are been combining, there is certain loss of your energy. So that will be called as of your mass defect. అర్థమైందా?
Yes, sir.
అంటే లైక్ సే ఫర్ ఎగ్జాంపుల్ నీ దగ్గర మాస్ ఆఫ్ యువర్ ప్రోటాన్ వచ్చేసి 10 ఉంది అనుకో, మాస్ ఆఫ్ న్యూట్రాన్ వచ్చేసి 10 ఉంది. ఈ రెండు కంబైన్ అయితే మనకి ఎంత రావాలి? 20 రావాలి. కానీ ఇది అవ్వడం లేదు. ఈ 10 ప్లస్ 10 ఇన్వాల్వ్ అయ్యి ఏమైపోతుంది అంటే మనకి 18 వస్తుంది. అంటే దాంతో పాటు ఏమైపోతుంది? సర్టన్ అమౌంట్ ఆఫ్ లాస్ అవుతుంది. ఈ లాస్ ని మనం ఏమంటున్నాము? మాస్ డిఫెక్ట్. అర్థమైందా?
Yes, sir.
అంటే ఎవరి మాస్ ఎక్కువ ఉంది? మాస్ ఆఫ్ రియాక్టెంట్స్ ఎక్కువ ఉంది కదా. దిస్ 10 plus 10 is more. So this one minus of 18 will give me this loss కదా.
Yes, sir.
So that loss is known as of your mass defect. Clear?
Yes, sir.
Very important formula. Regular Gaussian JEE means ki you will damn sure will find one question in this one when you're writing this year also the exam basically. Okay, so when reactants
Yes,
are
sir.
combining to form a stable product, there is a loss of your mass. That loss in the mass is only is called as of what? Mass defect. That is given by the formula delta M is equals to Z into Mp plus A minus Z into mass of neutron minus mass of your nucleus. Clear?
Yes, sir.
How do you calculate this mass defect, beta? Mass binding energy relation EB will be equal to mass defect into your C square. Energy kada. So energy is equals to delta M into your C square.
Sir, what is C?
C is the velocity of light.
Okay,
Okay.
okay, sir. Yes,
Provided
sir.
if delta M is given in AMU, in atomic mass unit. I hope you know it. One atomic mass unit is equals to 1.66 into 10 to the power of minus 27 kg. Okay.
Yes, sir.
So if delta M is in your AMU, I can write that binding energy will be equal to your mass defect delta M in your AMU. In your AMU multiplied with your 931.5 MeV. So this will be the formula. Okawela, the mass defect is in AMU, you need to multiply with your 931.5 MeV. If it is general, then you can directly use the formula binding energy is equals to your delta M into your C square. Okay,
Yes, sir.
very important relation. If binding energy or mass defect, if the mass defect is in your AMU, then binding energy will be equal to your that mass defect into 931.5 AMU. So that is 1 mega electron volt. Yeah.
Yes, sir.
Next one again very important. Binding energy per nucleon. Binding energy per nucleon. కెమిస్ట్రీలో కూడా వచ్చింది గుర్తుందో లేదు నీకు.
Yes, sir.
This is your element X, this is your Z, this is your A. A is what beta? Number of nucleons, isn't it? Z is your what? Atomic number. Binding energy per nucleon ఎలా రాస్తామన్నా? Binding energy per nucleon. Per nucleon is right now for me EB divided by A. What is A? A is nothing but number of nucleons. A is your number of nucleons. Nucleons అంటే total mass. అంతే కదా?
Yes,
Binding
sir.
energy
Yes.
per nucleon is equals to your EB divided by your A. A is nothing but of your mass of nucleons. ఇక్కడ గుర్తుపెట్టుకోవాల్సింది ఏంటంటే binding energy is lower for all the nucleons whose mass numbers are lesser than 30. Okay.
Yes, sir.
What is this condition? Binding energy is lower for A lesser than of your 30 and also for your A greater than of your 170. Lesser than 130 ki binding energy is lower, and for all the mass numbers greater than of your 170 is also the binding energy is lower. Now what does this binding energy per nucleon tells better idea on the Niku? It will tell you how stable the nucleus is. It tells how stable is a nucleus. Okay. Is it clear?
Yes, sir.
So what is the binding energy per nucleon? So binding energy per nucleon tells you about your how stable the nucleus is. How when it will become more stable beta? Binding energy is been lower for what? For all the number of nucleons whose value is lesser than 30, and for all the number of nucleons whose value is greater than of your 170. Okay, now?
Yes, sir.
Kudo sir, Molo sir, if there is any doubt in that one.
No, sir.
So can I say that greater the binding energy, greater will be the stability of nucleus beta?
Yes, sir.
Isn't it? So can I say a term right now here? Greater the binding energy, greater is the stability of nucleus. Ante kada?
Yes, sir.
What is the condition I told you right now? Like say binding energy per nucleon is nothing but of your, this is your nuclear binding energy divided by your mass number. Isn't it? So if I'm drawing a graph for this one, you see one basic graph is there, very important. Here we are taking binding energy per nucleon, and here we are taking your mass number. So the graph goes something like this. Then comes down, then increases, then comes down, then becomes stable, then becomes like this. And it is maximum stable for your mass number of your 50 to your 140. Then afterwards it decreases up to your mass number of your 240. Okay?
Yes, sir.
Sir, this graph is very important. Here we are taking what? A and A in the mass number. And here we are taking the binding energy per nucleon, and this one is in your mega electron volt. Okay?
Yes, sir.
So 50th element and almost like of your iron is having more stable, like 56 Fe. Okay? This is the more stable of all the nucleus. More stable is right now. Iron. Iron is of your more stable. Okay, na?
Yes, sir.
Let me give you one question on this one. How the questions are being framed on this one. J means learning a question. If M0 is the mass of an oxygen isotope, like O817, MP and Mn are the masses of a proton and a neutron. Okay, the nuclear binding energy is of isotope is. First read the question carefully. Options given are M0 minus 4 times of mass of your proton into your C square. Second option is given as M0 minus 8 times of mass of proton minus 9 times of mass of neutron into your C square. And the third option is M0 into your C square. And fourth option is M0 minus 17 times of mass of your neutron into your C square. See the question. If M0 is nothing but what beta? Mass of your oxygen isotope. Mass of your oxygen isotope. MP and Mn are the masses of your proton and neutron. The nuclear binding energy of isotope is given by binding energy. Binding energy is equals to mass defect into C square. Kada?
Yes, sir.
So how do you write the mass defect? How do you write the mass defect? How do you write the mass defect? So mass defect is equals to mass defect is equals to Z into mass of protons plus A minus Z into mass of neutrons minus mass of your nucleons. Oh, na?
Yes, sir. Yes, sir.
Ante I can write here mass defect will be mass of nucleons is right now the isotope kada total mass of this one is m naught minus mass of your protons 8 times the mass of your protons oxygen isotope kada avuna kada protons will be
Yes,
how much
sir.
for me 8 number of neutrons will be equal to how much a minus z ante 17 minus 8
Yes,
enta
sir.
17 minus 8 enta
9.
9 times of mass of your neutron into your c square. See, the basic question అడిగాడు J means లో. So which option will be your answer, beta?
Second
Second
option.
one will be the answer. What an idea?
Yes, sir.
Any doubt in this one?
No, sir.
So next one, beta. Nuclear fission and fusion. గుర్తుందా?
Yes, sir.
What do you mean by fission, beta? In the fission, if I am writing
Joining of
addition,
molecule.
yeah, some element X is there, it is getting bifurcated, it is giving you some Y plus certain amount of Z plus certain amount of your energy with this. అవునా కదా ఫ్యూజన్ అంటే ఏంటి స్ప్లిట్టింగే కదా fission means what splitting
Yes,
splitting
sir.
of your stable nucleus into your unstable nucleus into stable nucleus with certain amount of your elemental emitted and with certain amount of your energy అవునా కదా
Yes, sir. Yes, sir.
ఫ్యూజన్ అంటే యాడింగ్ కదా
Yes, sir.
అంటే like say A plus B gives you some C plus with that one certain amount of your energy. That means this one is nothing but what? Joining of your nucleus.
Yes, sir.
Joining of your nucleus is known as of your fusion. So this is your fusion. Fusion is nothing but equal to your splitting. And fusion is nothing but of your adding. Fusion is nothing but of your adding. So splitting is known as fusion and joining is known as of your fusion. And in both the cases, beta, energy is released. In both, energy is released. Okay, like say if I'm writing delta E1, how do you write the delta E1? Delta E1 will be equal to mass of your A plus mass of your B minus mass of your C into your C square. The same way, energy released in the fission, delta E will be equal to your mass of your X minus mass of your Y minus mass of your Z into your C square. Clear?
Yes, sir.
చూడు మరోసారి వెరీ ఇంపార్టెంట్ రిలేషన్ జేఎంఎస్ లో రెగ్యులర్ గా వచ్చే క్వశ్చన్స్ ఇవి బేసికలీ ఫ్యూజన్ అండ్ ఫ్యూషన్ లో హౌ డు యూ క్యాల్కులేట్ దిస్ ఎనర్జీ ఇన్ బోత్ ద ఫ్యూజన్ ప్రాసెస్ వాట్ ఈస్ హ్యాపెనింగ్ బెటర్ కెన్ టెల్ మీ ఇన్ బోత్ ద కేసెస్ energy is being released and how do you calculate that released energy that is important right now for me. So delta E1 is in your fusion, that is mass of your A, mass of your B minus mass of your C, whereas in the fission mass of your x minus mass of your y minus mass of your z into your c square. Clear?
Yes, sir.
Now see, whatever this energy released or given supplied, that is called as of what beta? Q value. Like say if I'm giving you some condition here, keep a small note. Energy released. Energy released. Will it be positive or negative? Obviously it will be positive. Or energy supplied. When you are supplying energy means it will be what? Negative. So that is called as Q value. What is energy released or energy supplied? So whenever there is a release of energy, that will be positive. And when you are supplying certain amount of energy, that will be negative. That energy released or energy supplied is called as what beta? Q value. Okay. So the Q value will be equal to your mass defect into your C square. So this is the way how do we calculate the energy released. What an idea?
Yes, sir.
So let me give you some examples based on this one. Very important. It is your alpha, beta, and gamma decays. Alpha, beta, and your gamma decay. Like first one, if I'm talking about alpha decay. What's on the alpha decay?
Yes, sir.
So what is released in this one, beta? Helium nucleus. Like this is X, Z, A. When it is undergoing an alpha decay, it will give you a daughter nucleus whose atomic number decreases by 2 and mass number decreases by your 4, plus it will be your alpha particle released here, that is nothing but 2, 4 plus certain amount of your energy.
Yes, sir.
Now this energy, whatever is being released, it is in the form of kinetic energy. So this energy released is in the form of kinetic energy. Okay. Now tell me, how do you calculate the value of Q for this one? Q value will be equal to your mass defect delta M into your C square. And then,
Yes, sir.
so Q will be equal to your mass of your X minus mass of your Y minus mass of your, what is alpha particle here right now I'm taking? Mass of your alpha particle into your C square. So that will give me the value of your Q. I hope you got an idea how to calculate the Q value in the alpha decay. Done?
Yes, sir.
See here, the daughter nucleus, whatever is being formed right now, beta, this is your Y. This has been formed by liberating what? An alpha particle, kada? So alpha particle
Yes,
which has
sir.
been liberated will go in the frontal direction, beta. That is nothing but of your V alpha particle. And this daughter nucleus will be moving in the backward direction with a velocity like say Vy. And this is the mass of your daughter nucleus and this is the mass of your alpha particle. As there are their internal forces, so momentum is conserved in this one, beta. As momentum is conserved, I can say that mass of your daughter nucleus into velocity of your daughter nucleus must be equal to mass of your alpha particle into velocity of alpha particle, isn't it?
Yes, sir.
So from this one, I can calculate the velocity of your alpha particle is equals to mass of your alpha particle. Sorry, this will be equal to your what is the relation, beta? Mass of this one will be mass of daughter nucleus, velocity of daughter nucleus divided by mass of your alpha particle. If it is asking the velocity of alpha particle or the particle which is been liberated, you can use directly this formula. Okay. Now, what is the kinetic energy? I told you kinetic energy is in the form of Q. That will be equal to your half into mass of daughter nucleus, velocity of daughter nucleus, plus of your half into mass of your alpha particle, velocity of your alpha particle. So this will be what? Kinetic energy of alpha particle. Antena? So this is my equation number 2 and this is my equation number 1. Clear, beta?
Yes.
Any doubt in this one?
No, sir.
So however this equation beta, see here, when this stable nucleus, when this one X element is being forming into a daughter nucleus and alpha particle, during the formation of this daughter nucleus, it is liberating an alpha particle. That means this is an internal process property, momentum is being conserved. So this is the reason I'm telling you right now, initial momentum will be equal to final momentum. So from that one, I got the velocity of your alpha particle particulation, and that value I can substitute in equation number 2, and we can get the value of kinetic energy of your alpha particle. Okay. Is that clear?
Yes, sir. Yes, sir.
Like see from equation 1 and 2, from 1 and 2, we can get kinetic energy of alpha particle. Okay, no?
Yes, sir.
So this Q will be equal to your half into mass of your Y into, can I write the value of your Vy from this one beta? Vy will be equal to how much beta? Mass of alpha particle, velocity of alpha particle divided by My. So here I can write this one as of your m into your alpha, v into your alpha divided by m into your y whole square. Plus this will be your kinetic energy of alpha particle. Then,
Yes,
so this
sir.
Q will be equal to your half into your mass of your y into your m into your alpha square, velocity of your alpha square divided by your m into your y square, m into your y square plus kinetic energy of your alpha particle. So this my and this will get cancelled. So Q will be equal to your mass of your alpha particle square V alpha square divided by 2 times of mass of your daughter nucleus plus of your kinetic energy of your alpha particle. And then
Yes, sir.
still I can do any calculations there, but I need only the kinetic energy of your alpha particle.
Yes, sir.
I can simplify this one still. So if I'm simplifying this one, I will be getting kinetic energy of your alpha particle will be equal to your total cube into your mass of your daughter nucleus divided by your mass of your alpha particle plus mass of your daughter nucleus. This will be the standard relation. Okay.
Yes,
So
sir.
that shortcut formula you can remember. Kinetic energy of alpha particle will be equal to your energy released cube into mass of your daughter nucleus divided by sum of the mass of alpha particle plus mass of your daughter nucleus. That means I can even write this one like this. Kinetic energy of alpha particle is equals to Q. Mass of daughter nucleus ante enna A minus 4A kada divided by
Yes, sir.
mass of alpha particle ante enti. What is the mass of alpha particle, you tell me? What is the mass of alpha particle? Alpha particle mass enta 4. Atomic number
Yes,
enta
sir. Yes,
2.
sir. 2.
Ante kada.
Yes, sir. Yes, sir.
So mass of alpha particle is nothing but equal to your 4 plus mass of your Y ante daughter nucleus. Mass of your daughter nucleus enta undi right now? Z minus 2.
Yes,
Okay,
sir.
no? This one Z minus 2 plus this will be your Z minus 2. ఎంత అవుతుంది చెప్పు? అరే సెకండ్
Sir,
టోటల్
మొత్తం
మాస్
వేరియబుల్స్
నెంబర్ కదా
వస్తుంది.
ఏ అని రాసుకోవచ్చు కదా లేకపోతే మొత్తాన్ని mass of alpha particle plus mass of your Y can be written as of your A. అంతే కదా?
Yes, sir.
So you can even write this one as of your A. This one is also written as of A. So this is the kinetic energy of your alpha particle. Very important relations. Kinetic energy of alpha particle is Q into M into Y divided by M alpha plus of your mass of your Y. Or else Q into A minus 4 divided by your 4. Clear?
Yes, sir.
Any doubt in this one?
No, sir.
చూసుకున్నారా సార్ ఆల్ఫా డీకే అర్థమైందా వెరీ ఇంపార్టెంట్ రిలేషన్స్ దాన్ని సో మనం యాక్చువల్ ఏం రాస్తున్నాం న్యూక్లియర్ ఫ్యూజన్ అండ్ ఫ్యూజన్ లా ఐ టోల్డ్ యూ దట్ ఫ్యూజన్ ఇస్ నథింగ్ బట్ ద ప్రాసెస్ ఇన్ విచ్ ఎనర్జీ ఇస్ బీన్ like say it is a splitting and it is releasing your energy. and you are combining, it is absorbing the energy and it is forming into your stable nucleus. So fusion is nothing but of your combining or joining. In both the processes, energy is being released, and that energy release is being calculated with the formula delta E1 is equals to your mass of your A, mass of your B minus mc square, and delta E2 will be equal to your mx minus my minus mz c square. Now in this process, what I'm telling you, beta, if energy is being released, you take that one as positive. If you are supplying the energy, you take it as of your negative. So that energy is being given by the formula Q is equals to delta M into C square. The first example in this one I took is right now alpha, beta, and gamma decay. For alpha decay, it is in helium nucleus. ZXA will give you the daughter nucleus and alpha particle. So this in this one, energy is being released in the form of kinetic energy, and that is given by the formula Q is equals to your m alpha minus my minus m alpha c square, isn't it? So velocity of alpha particle is given by this formula, and total kinetic energy of alpha particle is given by this form. This formula directly you need to remember better, or else you can directly remember this form.
Yes, sir.
Okay. So we'll be doing complete this one today if it is possible. We'll try to take one class in the evening. Possibility unda na evening emana 9. We'll keep the full stop for the nuclear physics and we'll try to do the numericals based on this.
Okay.